Hello, Year 8. We are back for another episode of Mathematics. Today we are going to be going through surveying and sampling, leading into exercise 8F. All right, so surveying and sampling. Look, the whole reason that you do a survey is you want to get an idea of opinions, views, and you do that by getting a group of people and you ask them questions. They can be different types of questions. They might be questions that give you yes or no. Do you agree with the colour of your socks? Maybe a yes or no sort of question. It could be a survey of something very strange. I've just been out on a bike ride with my children. So it may be something like, how many bicycles do you have in your home? Which has a number response. So you're expecting that people will probably respond 1, 2, 3, 4, something like that. A lot of them, and a lot of really fascinating surveys go on asking people's opinion. And, we could really stir you up here and take some controversial topics. How do you feel about online learning? Strongly agree, neither disagree or agree, disagree or strongly disagree. It's fascinating. I actually really like surveys. They provide fascinating insight into what people are thinking. I particularly love political surveys. They're just fascinating, seeing what people are thinking about different issues and that sort of thing. One of my favourite providers of this data is a group called Essential Research. If you Google Essential Research, you'll see they ask lots of really controversial and interesting questions of people. And they'll ask about 1,000 people throughout the country in different locations, different ages, different male and female, all that sort of stuff, and it's really fascinating stuff what they come out with. Anyway, it might not necessarily be your cup of tea, so I'm just going to get down to what we... That's on a video now! Anyway... Why am I here? Anyway, so look, surveys, as discussed, they're ways of taking a small number of people and seeing what they think about a subject. Now, the accuracy of samples becomes important, right? So we are here, what can affect the accuracy of a sample? Things like this, sample size. That's the number of people we serve. No, behave yourself. This is going on the internet. This is my Year 8 kids. Now, sample size is... All right, sample size is a number of people you are sampling. So close the door, please. If you are sampling only about 10 people, then you might not get an accurate idea of general views about whether people like the current colour socks or not. Generally, you want to survey a reasonable number of people. Close the door, boys! Right, and you want to survey a decent number of people to get an accurate picture of actual perceptions. Like this Essential Research and most proper surveying places, they tend to survey about 1,000 people across the country to get a good feel for the actual perceptions of things. If I only surveyed 2 people that I ran into walking down the street, it's not going to be an accurate survey. Another thing is whether the survey is representative of the larger group or it's biased. And, off the top of my head, if you sampled people about climate change at a climate change rally, you're probably going to get this perception that, everyone believes there should be dramatic action on climate change. However, if you survey people randomly using, who knows, phone numbers and other information, you get a different picture. You can always sample people that are going to give you the answer you want to hear, but that doesn't make good statistics. It's not real. You need to make sure that when you are picking people in a survey, that they are representative of a greater population. And you don't want them to be biased. Biased means, look, those people obviously have a particular leaning to start with. I always remember some of the materials you get, some of the surveys you get from politicians. There's only a certain proportion of people who ever respond to those, and they don't tend to represent the broader population and what they're thinking about, because it's only people who are sitting there who've got the time to read it, to give feedback. It's not the most accurate in the world. And these become quite big issues when you're doing political surveys and things like that. One of the most interesting things is in that 2019, there was an election, a federal election for the whole country. And there were, essentially what happened was the surveys were all saying that the election was going to go a certain way. And then on the day, it went the other way. The other way was only a difference of 2%. You're not talking about a big difference here. But how that happened is a fascinating story of statistics. And part of it comes back to, were the people being surveyed for those political surveys actually representative of the population? And one of the theories there was that a lot of the people that would have given a more accurate picture were just too busy working to give that accurate picture. Another example of where I could demonstrate that samples go really, really wrong is the internets. Now, we all love the internets, but random surveys on the internet are shocking. Ones that are done by news organisations or places like Twitter. I mean, who would have thought that a place where your entire life is explained in 140 characters at any moment in time could be bad? But there are some terrible, terrible surveys on Twitter. I have one here that I use with some of the older classes that you may or may not appreciate. It was done by a politician many years ago, but look, I find it hilarious. You're probably going to go, what's so exciting about this? It was asking us, how should the government spend the $5 billion that it currently spends on green energy? So things that encourage solar or other initiatives other than using coal-based electricity, coal and oil-based electricity. And naturally, this is put on Twitter. Now, you can see that something very strange has happened here, in that 87% of the respondents have said that the money currently being spent on green energy should continue to be spent on green energy. And that's obviously because a whole heap of people have gone on here and pressed a particular answer to, well, give this politician grief. Twitter. It has to be an extraordinarily unreliable way of doing a survey. Now, I have to point out, I'm not actually expressing an opinion here. My opinion? I hope you can't pick it, because teachers have no opinion on anything ever. Now, going on from that, what do we want to talk about next? So the other thing, so that's talking about bias and whether your sample is actually representative. The other thing, you've got to be careful about errors. So you can have errors in your data. You know, if you're going around asking how many bicycles are in a house, some person could shove in a stupid answer like 624. You're probably not going to have 624 bicycles, but some idiot will give you that answer. You need to be careful of that in your data, because that's going to cause problems in your entire analysis if someone puts in some really, really weird value. So you've got to look out for extreme values. Those extreme values we call outliers. So extreme values we call outliers. And yes, they can cause untold damage to your mathematical analysis. And you don't want that to happen, because we all love the mathematics, right? Now, the other thing we need to point out is data can be symmetrical or skewed. What that means is when you draw a graph of it. I'm going to draw 3 graphs. I wish I had more room, but you know, we do with what we can. If you get kind of a pattern like that, a bell curve sort of pattern, you would call that symmetrical. It's the same either side of the middle. I could cut that in half and flip it and it'll be the same. So there's a clear middle and there's clear values either side. The sort of things that look a bit like that if you graph it are things like male height or female height. There tends to be a middle and then it drops off somewhat evenly on either side. There's a lot of data that, well, you know what, there's not actually a huge amount of data that if you want to be technical is symmetrical, but it's interesting to look at. And, you know, weight can be a bit like that. But there's all sorts of data that, yeah, you've got a middle point and it sort of drops away evenly either side. There'll be examples in the text you can look at as well. Skewed data looks more like this or this. What it means is skew is all about the tail actually. The tail is the long end of it. See how there's a tail out there extending out to the left? Well, this one has this big tail extending out to the right. At year 8 level, we just call either of these skewed. But I may as well show you skewed. This here is viewed as skewed to the left because the tail's on the left. So you'd see that as skewed to the left because the tail's on the left. This one here, the tail's on the right. Want to have a guess what I'm going to call it? Skewed to the right. All right, so that's the basic idea. Data's either symmetrical or skewed, and I've advanced it a bit more than that. In these questions, you're going to get, they're just going to ask if it's skewed or not, symmetrical or skewed. So it's either main middle point going off either side or it's skewed. So as an example now, I think that's, I can introduce a bit more theory. Here, the middle value is going to be about where I've drawn that line. The middle value, you'd know from previous lessons, is the median. So here the median is going to be about there because half the data is below and half the data is above. And in turn, the mean, where you'd add up all the values, the mean is going to be straight in the middle as well. So in this sort of situation, the mean and the median are equal. Here, with the tail to the left, what ends up happening is your mean ends up being to the left over here, and your median ends up being over here. The really low values pull the mean down. So, boys, volume please. Right? So in here, in these situations, the mean and median are different. Here, the mean and median are the same. Here, the mean and median will be different. In this one, the mean will end up being less than the median. Over here, the mean will end up being more than the median. Because those big values are going to pull the mean upwards. Right? Now, that goes into more advanced considerations of this content, which we won't go too far into today. Now, look, the second thing I've got to do is actually show you some of the typical mathematics questions you're going to get. To do that, I've made up a survey here. Now, obviously, my drawing here is not going to show as beautifully as the one in the text. The text is a different example. However, I've decided to survey 100 people for how many bicycles are in their house. I'm going to put the actual data values on here to help in case it doesn't look too clear from where you're sitting. So the idea was 100 houses, how many bicycles do you have? That's actually 30 there, so 30 houses have 0 bicycles. That's meant to be 20, 15, 20, 10 and 5. Now, if I was thinking clearly earlier, that should add up to 100. 30, 50, 65, 85, 95, 100. So I did make that example correct. 100 houses surveyed, that's how many bicycles they have in their houses. All right, I'm going to rub this off because I'm going to keep going with actually answering questions here. Now, the sort of questions you could be asked are these. How many houses have 0 bicycles? For that, you should be able to look at the graph and go, oh, how many homes have 0 bicycles? 30. So your answer would be 30 bicycles. Right, what else can we ask? What proportion of houses have at least 4 bicycles? Right, for that one you're going to look here, and at least 4 means 4 or above. So how many houses had 4 or above? You should say 15, right? But it's a proportion, so it's 15 out of how many houses? 15 out of 100. Now, I put an equals there. Do you know why I put an equals there? You should notice that you can simplify that. Now, as I've explained before in class, and this depends. If you are looking at mathematical methods in the future, I want you to be able to do that by hand. If I did that by hand, I'd be going, what's the biggest number that goes into both of these to simplify it? The biggest number that goes into both, I reckon, is going to be 5. They're both divisible by 5, but not 10 or 15. 15 doesn't go into 100. Divide both the top and bottom by 5, you'll get 3 over 20. But if you are not looking at mathematical methods in the future, you want to stay in the general mathematics path, you can always enter it in your calculator as 15. Press the fraction button there. Remember, you've all got a fraction button, even for different calculator. 15 over 100, put that in your calculator, press equals, it'll simplify it for you to 3 over 20. All right, but again, if you're going to mathematical methods in the future, be able to do it by hand. Otherwise, your calculator can help with that. Now, that's proportion, right? Notice the difference between those questions. That one just asked how many, so you give a pure number, but proportion, we're expecting a fraction or a percentage or a decimal there. It's got to be relative to how many people were surveyed entirely. Right, third type of question then, you could be asked in a group of, let's say 80,000 homes, how many would be expected to have 3 bicycles? Now, for this sort of thing, it's actually 2 steps. One, you need to find the proportion. Once you have the proportion, you can multiply it by the number of houses. So if I was looking at the proportion, how many had 3 bicycles? There were 20, right? 20 of them had 3 bicycles. That's 20 out of 100. And you simply multiply that by the number of homes. Again, for mathematical methods directed people, whoa, I wrote 1,000 there. It should be 20 over 100. For mathematical methods people for the future, you should be able to do that by hand. But there it is in a calculator. If I put it in a calculator, I would expect 16,000 homes. If you want to know how I do that manually on my end, well, drop 2 zeros there, drop 2 zeros there, it'll be 20 times 800. If you remember your rules of multiplication, that means you'll have 3 zeros in the answer and then 2 times 8 on the front. So 2 times 8, 16. With 3 zeros, it'll be 16,000 homes. That's how I do it without a calculator. All right? Now, I'm going to finish up very soon because I've hit 20 minutes and I don't like to go too long for you guys. Which distribution, is this distribution symmetrical or skewed? Right? If it was symmetrical, we'd expect a nice bell curve with a peak in the middle. It is not symmetrical, is it? Right? So the distribution is skewed. Right? The distribution is skewed. And if you wanted to go beyond year 8, I'd say the tail, where the tail goes out is to the right. I could say it's skewed to the right. Some texts call that positively skewed because it's skewed upwards. Whatever, skewed to the right, skewed positive. And what I think that'll probably do for today, ladies and gentlemen. That's an introduction to surveys and samples. A lot of it is a bit more theoretical rather than mathematical. You do actually think, what makes a good survey? What makes it work? And yeah, you need to think, you need a decent sample size. You need to sample a decent number of people if you want it to be accurate. It needs to be representative of the greater population. Like if I was trying to survey a school on opinions, I wouldn't just survey year 7s because there's a whole school out there, isn't it? I wouldn't just survey males. I wouldn't just survey females. I wouldn't just survey any particular group. If you want an idea of what people in the school think, you need to survey all different people of different backgrounds and different thoughts, or you're not going to get a representative look at it. And you need to make sure, there aren't errors in your measurements. The people who say they've got 624 bikes, go look for errors, look for extreme values because they're going to cause issues in your calculations and how you interpret it. From there, yes, you need to be able to look at diagrams. You need to be able to tell us whether they're symmetrical or skewed. You need to be able to do the mathematics of it, how many proportions, which end up being a fraction, right, and can be a decimal. And you need to be able to answer questions like this in a group of 80,000, which is that two-step process. Find the proportion, multiply by the number of events, you get an estimate of the answer. That's what you need to be able to do. All the best. Have fun.